Hmm. All right, so I think we are live. This is, yeah, let me put it here somewhere. All right, so good evening, everyone. I hope my screen and my audio is uh, clear to you. I think it's streaming well. Can somebody confirm? Is it okay? Yeah, great. Thank you very much, Atanya. So today's session is third in our series. Good evening, everyone. And we are going to discuss about very basic thing, that is analyzing the simulations result and then generating the reports on the basis of that. I'll be taking very simple uh, uh, process, and I will be taking very simple use cases so that you should be able to scale them up as per your particular requirements. So again, the session, I try to keep this session till 10 o'clock only. uh, the flow will be similar, like for the smooth conduct of session. If you have already attended my previous seminars, this is the repeated slide. So by default, everyone's mic is mute, and please do not unmute yourself to avoid any confusion. Even though I've given I think I haven't given any rights to you for unmuting right now, but late in the last 10 minutes of this session, we can have our discussion, and at that point of time, I'll be unmuting everyone, right? So whosoever wants to discuss, they can discuss correspondingly. Then a flow of this session is like I'll be talking about these 3 points. One is understanding about the simulation. So I think for chat we can do it later on. So uh, the very first topic which we are going to talk about is the understanding sample scenarios, and where we are trying to see that what is the result and what are the different entries which are being displayed on the console and what they mean, right? So that is the very first priority. We should be able to understand that particular part. Second is observing the multiple results in the simulation run. Now most of the time we need to do the comparisons with different set of parameters. So if we wanted to have that particular uh, thing to be done, then how we can do it more conveniently, and how it can be recorded, that is more important, and that we are going to go and see inside generating reports from the sample use cases, right? So these are the three things which we are going to go through. Again, this particular session will be a part of this conceptual discussion, and part will be the demonstration part. So I've already configured Cloudsim 3.0.3 on my particular Eclipse ID, and I think there are a couple of new attendees in today's session. So I was going through the list of responses that was submitted in response to what I sent as an email request to you all. First of all, thank you very much to those who has actually submitted their particular problems, the challenges which they are facing in the Cloudsim, and there have been 30 entries. I just wanted to crawl through these. This is what I got from you guys, and this is quite detailed, and I could able to understand that yes, these are some of the challenges with what you guys are facing. So this on the basis of this, this is one topic which I actually chose for this particular seminar, and because a lot of people have asked for this particular part, that how we are going to analyze the results and how we are going to utilize this particular part for generating the reports. So that is why we are here for this particular thing. So let's start with the basic first point, that is understanding the sample scenario simulation results. So if I go to this particular site, so just a quick refresh for the Cloudsim simulation flow. So there are certain step of sequences which are being there for any example scenario that is there in the Cloudsim. And if you see, we start with initializing the particular Cloudsim simulation, right? And that is the very first thing. This is the place where we are able to have all the initialization, especially the cloud information service. This is the instance which has been generated, and this is one class within the Cloudsim which is going to hold all the entities detail, with specifically compute resources detail. Then we create the data center, then the broker is created, right? So this is what is the data center I'm talking about. This is the broker where it is in the complete simulation flow. And then we create the virtual machines and the cloudlet. Cloudlets are basically tasks, and virtual machines are basically the abstract version of the physical resources. And then those both of these VMs and cloudlets have been submitted to the broker, and the simulation has been started. So all these steps are basically only telling the system of simulation that how the particular configuration will be for the complete simulation components, right, or models. Whereas start simulation is actually the one which is going to do all the simulation in one go on the basis of all those configurations for a certain period of time. And once it is done, the simulation is stopped and the result is printed. So this is the point where we are actually trying to concentrate today, that how the results are being printed. So just to have a flow, this is the broker. Once it gets started, it can be submitted with the cloudlets, and broker knows that there are certain set of VMs which are supposed to be placed on the data center. And these there can be more than one data center. So these data center will have their host, and on host those virtual machines are being hosted. Now before sending all the requests to the data center, the cloud information service is requested by the data center broker to share the details about the particular uh, set of compute resources that are available in the simulation, right? And once they are there, that means then broker is eligible to send the cloudlets and the virtual machine to that particular data center. So this is what is the basic flow. That is what we have for a particular example, right? So if I bring you to the particular code, so here what we have is, these are the examples. I'm talking about the simple example right now. So within example one, this is the very first step where you initialize. This is the second step where we create the data center. This is the third step where we create the broker. Then we create the virtual machine and we submit it to the broker till this particular place. And then we create the cloudlet. Then we submit it to the broker till this particular place, right? And then the simulation is being started and simulation is stopped. And the last step is printing the results that are being, they are in the particular system, right? After the simulation is over. So this is all. This particular set of or piece of code is written inside the main method, right? So that is what we have in terms of our basic structure, so that the people who are new to the Cloudsim, they are not, who are not even aware about it, they should be able to follow the process. So overall, this is very simple. This might look kind of very bulky in a set of code, or bulky in set of kind of network setup, but it's not. It's quite simple once you understand that, okay, there are certain number of steps which are supposed to be followed, and there are certain type of configuration which are supposed to be done. Then you are able to go through with all the things, right? So let me take you back to the presentation. So here, the very first point, the actual agenda, right? And actual agenda, if we talk about the agenda, the very first point is understanding the sample scenario results. So the very first thing that you should understand is the when we run the particular example, an output is being displayed on the console, right? And most of you might have, who has actually worked on this particular system, know that what sort of output is there. So let me run a sample for you, and that sample is like, let's say I run this particular Cloudsim example one. So once I execute this, what you get to have in your system is this particular set of output that has been displayed on the console once you run it. Now, if we look at this particular set of output, this output is can be categorized into two ways, right? So the very first is console output displays the simulation log, right? So whatever happened during the simulation, that has been displayed in this particular console log, right? And each and every information, if everything is going fine, is there any kind of failure happened during the simulation? Is there any kind of error happened during the simulation, which could be because of the Java syntax error, or which could be because of some kind of runtime logical error, and so on. So everything will be printed on the log. Whereas the second section is actually going to give you the execution status of the cloudlets with the additional detail, right? So status of cloudlets is being printed, because at the end of the day, what you are doing is you're simulating the configuration of your cloud system, and then on that particular simulated cloud system, you are putting in your workload, right? That is what you are trying to do, and that is how you are going to do a simulation of real world cloud on the cloud sim, right? So ultimately, that is what you are going to do. So task or workload is something which is supposed to be analyzed correspondingly. That is the reason that this particular section of your console is going to give you the status with respect to the whatever the workload you have submitted to the simulation, and what has been the results on that particular workload execution, right? So this is the second section, and this is the first section. So this, till this particular place, the console give you that what has happened during the particular simulation, whereas the second part displays you the status of your tasks which were being submitted. So to understand more about it, let's go to example 6 and run it again, right? So that we should be able to have a better understanding of our overall results. So I think in last session we did some changes to that. So let me do it for the example 5. So here, if you look at this particular prospect of output, you can see some difference in the particular log, simulation log, and the output as well, right? So there are two different outputs which are being displayed, and there has been different set of logs which is there, right? So similarly, for Cloudsim example 4, you will have a different set of output, right? So here you can see there is here the simulation log is a bit different, and the output for your cloudlets are in the same section. They are not in the two other sections. Now, why this happened? Just to give you a brief, if you look at this particular part, there is only one broker which has been started within Cloudsim example 4, whereas inside Cloudsim example 5, you can see there are two different brokers which have been started, right? So each individual broker resembles a user. Okay, and that is why for each user, whatever the number of cloudlets were submitted, that printing has been done correspondingly. So every example will have is having a different kind of use case implemented inside it, and it depends upon your interest at what example you wanted to follow. So just to give you a brief about it, that is why I've executed these two examples. So let me bring you back to the example 1 again, so that with the simplest log we should be able to understand that what is happening and where it is happening, so that in case if you want to change that particular log, you should be able to do it. So let me run this again, and let's start analyzing that what exactly this output is, right? So let me do a snippet here, so that we should be able to do some analysis correspondingly. All right, so this is what I have. So this is what is the output. So let me make it, let's save it to some PFG, right? Capture, desktop. So this is what we have. So if you look at this particular part of output, so I think we can annotate. Share screen, whiteboard, share. Just give it. Okay, so here I think we have. So if I look at this particular section, where is the image? I think. I hope you are able to see my screen, or it's just simple. Let me stop it again and share it. I think. So where is the desktop? Stop. So this is I have in terms of whiteboard as well. I don't know. Can somebody tell me, is it only whiteboard visible to you, or is it the complete screen you can see right now? Okay, it's all white. I'm so sorry for that. I'm quite new to this tools. Anyways, we go to this only. Okay, so here only. So within this particular part, right. So within this particular section, if we look at this particular section, this section only. So here, if we look at the particular part, what we can see is that it says start Cloudsim example 1, right? Then it says initializing, and then start Cloudsim version 3.0. So these are some of the logs which have been printed through the main method itself, right? So I think, okay. So main method itself. I hope right now you should be able to see my whole screen. So when I say main method, here you can see, oh, great. So here, if we look at this particular part, what it says that start Cloudsim example one. So this is from where this has been happening. Then if we go inside this particular init method, and then you will be able to see that, okay, it says that cloud information service has been initializing, right? Because this is going to have a init common variable init common variable function to be called. There it is going to print for a particular set. So it says initializing, so that means within the Cloudsim it is going to print the initializing part, right? So that gives you the second line, and then says starting Cloudsim version 3.0. So it's been inside your example, right? So that is where it is going to print you that particular part. So then comes is your data center 0 is starting, right? So data center 0 is going to be started from this particular part. So create data center. When you go inside the create data center, I'm just going to have open declaration here. And once you get inside this particular create data center, you go to the data center instance, and within this data center, you can go to the open declaration, and there you can actually see that before doing any of the initialization, it is going to call a super method. So if you are aware about the Java's or any object-oriented programming language, if there is any parent class, the constructor of the parent class is supposed to be called. So that is the sim entity which is going to be is going to be called first. So once you go inside the super method or sim entity example, you can actually see that from there it is going to add an entity to the Cloudsim, and this Cloudsim is going to this Cloudsim class is going to further print the no what do you call the entity starting information, right? So if you go inside this particular part, and then you can see that it is going to add a particular entity to the entity list, and then that entity list is going to get started through the start entity method that is actually inside the data center class, and that data center class is going to be here. So the printing happening at this particular start entity method itself, right? So the circle goes around and comes back to the data center class when it has been executing, right? Or when it has been simulating through the system, right? So just to give you an idea that how this particular simulation or how this particular log has been printed by following the complete path, uh, this is again very important in case if you wanted to print any of the debugging message inside this for printing on the log screen, then you should be able to do that particular part, right? So if this sounds confusing, then you should go to my YouTube channel, which is Superwits Academy. It's the name of the channel, and then there you can find out Cloudsim tutorial playlist. Within that, there is a third video which explains about all these particular set of steps that allows you to have an understanding about the complete set of steps that are happening within the simulation. So let me bring you back to the console output again. So here these first three lines, or even if you talk about the broker is starting, this all is being done during the initialization prospect only, right? So as soon as you create a particular entity, that is data center or broker, they are being called for their start entity method, and the printing is being done correspondingly, right? And once all the entities are being printed, all the entities are being started, then entities started method has been printed, and that is again comes from the Cloudsim uh, class, right? So this is where this is the point till what sorry this till this particular point. Sometime I fumble. So till this particular point, you're just only doing the configuration part. You're not actually starting with the simulation. As soon as you see this 0.0 in your log screen, this is the place where the actual simulation starts, right? So that means you are starting your clock for the simulation. So every time you run a simulation, your clock starts from 0. Okay. And once this particular clock starts from 0, after that, whatever the event happens with the certain set of interval, the interval here is basically 0.1, right? With the certain set of interval, you will find that there are other tasks are been happening, and all these tasks, whatever is happening, is basically happening on the basis of the interactions between the entities. Very specifically, I'm saying whatever the log now printed after this particular entity started part, and whenever you find this zero point 0 value, all the particular set of log, whatever is being printed or displayed on this particular console log, is basically the interactions that is happening between the different set of entities. Most of the time the entities or the parties involved are broker, data center. These are the two main entities which are being there, and there is a cloud information service which can also play some part in case if you are working on dynamic entity generation, right? Dynamic entity creation. So these particular set of logs are basically from the interactions whatever is happening between the entities. So you can see which entity is being in picture. So most of the time you will find broker is in the picture. So just to bring you back to the presentation, what we said is, when once all the configuration is set and the cloud information service knows about the data center, then the broker gets into the picture and the simulation gets started. So this is where it is being done. So broker is asking the cloud resource list from the cloud information service, which has been received to the broker at the initial point of the simulation, right? And then once the list has been received by the broker, that means the broker is going to send the request for VM creation on the particular data center. So that is what the second line in this particular log is displayed. Then at the interval, because VM request has already been sent, the broker VM0 has been created on the data center. So that means between these two particular point of time, the interaction happened between the broker sent a request to the data center, and data center has already processed that request, and uh, a response was sent back to the broker from the data center that yes, the VM has been created on this particular host. Now there is a confusion sometimes happens to the users that what these numbers are displayed. Every time whenever an entity is being created, it is actually created through the Cloudsim, right? And Cloudsim keeps a track of all the entities which are being created. The flow is, the very first entity which has been created in the system is the cloud is the cloud shutdown, then cloud information service, then data center, and then data center broker, right? This is what is a sequence that has been created. So if you look at the sequence, so that means the shutdown entity, the cloud shutdown entity will have the ID 0, whereas the data center cloud information service will have ID 1, and the data center will have ID 2, and the data center broker will have the ID 3. So if you look at this particular number, the number which has been displayed, data center hash 2, wherever you find hash, that is basically referring to the ID, right? Whereas if you look at this particular part, data center underscore 0, this actually comes from this particular place, because we actually created a data center with the name data center 0, right? So that is the reason the data center 0 is being displayed in that. Now this is something which is kind of confusing, but you cannot do anything about this, because the developers of this particular tool have not taken care of some of the anomalies. So you will find those anomalies, but you have to take care of that. Then once the VM is being created, then the broker is eligible to send the cloudlet to the virtual machine, because we know that there is a real cloud over the above, there is a virtual machine, and now we are eligible to run a workload over that particular virtual machine. So this is what the another log is going to do, right? So I think there is some message. Definitely you will have recordings. So next comes is, because the cloudlet has been submitted to the virtual machine. So at this particular point of time, the execution gets started, right? So between these two set of console outputs, what you will see is that the execution has started happening. So right now, example one has only one task, right? One workload. So that means cloudlet 0. So cloudlet 0 has been sent for the execution at 0.1 time, whereas once the cloudlet has been finished, it will come back to the broker. That means a response from the virtual machine will be sent back to the broker with the 400 point at 400.1. So that means the cloudlet 0 took 400 units of time for executing on this particular virtual machine. So in previous webinar, I've already explained about this, that how this particular execution happens. So whatever the number of length you have for your cloudlet, right, that will be divided by whatever the number of MIPS you have for your virtual machine. So once you divide it, you get the actual time which is being spent into this particular execution. So once this is being done, then the cloudlet 0 is being received and all the cloudlets once finished, that means broker's job is over. There is no need for further simulation. So it will destroy the virtual machine and that request goes from the broker itself. And then because the simulation is going to get over, so broker gets shut down, and there, because there are no future events, so cloud information service will also get shut down, and immediately the data center 0 will also get shut down. And then finally the simulation will be stopped, and whatever the output is there, that has been displayed on the screen. So this is what is the simplest understanding of the log which you can make from this particular set of example. All right. So the time is in seconds, because how we know that this is in second, because MIPS stands for million instruction per second, right? So whatever the unit time is there, that is in seconds, right? So this is what you have in terms of your basic log of any example, right? So that is what you get in terms of your particular system. So here what happens is, during the simulation, when you are trying to do some kind of changes to the code, you may run into some kind of error, which could be from the Java syntax error or some kind of logical error which happens during that particular run. Or maybe sometime it happens that you are trying to do some configuration, there is no error, but there is no output, right? So let me show you one of the example, because right now what we are doing is we are running an ideal scenario, right? So if I change the configuration of my virtual machine, I'm increasing the MIPS request by 10 times, right? Previously it was 1000, now it is 10,000. Now if I run this particular example, what you will find is that your output is not displaying, right? Now, if I am a novice, if I am a beginner, and if I have no clue about this particular log, I will not be able to figure out that what has happened. But if you clearly look at the logs, what has been happening till this particular point, everything is fine. Then broker sends a request to the cloud information cloud resource list. It gets a resource list. It tries to create a virtual machine on data center 0, right? And then what you see is allocation of virtual machine to host 0 is failed by MIPS. Right? If I'm not going to take care of my log, I'll not be able to figure out why the output is not there. So if you see, it says your allocation of virtual machine to the host is failed because of the MIPS parameter. So broker creation of virtual machine is failed on data center. None of the required VM could be created, so it's been aborted, and broker is shut down, and the rest all is same, right? So this is one of the reason why your log might not be there, right? If such is a case for you, right? So in this particular scenario, so if I wanted to have a higher configuration, so as in last webinar, I told you that you can just directly go to the data center, create data center method, and you can increase the MIPS, right, of that particular host processing element. And once you do that, you will be able to execute your virtual machine, and your output log will be displayed. Now you can see the time here is now 40. Previously it was 400, now it is 40.1, Now, why this happened? Because my MIPS has increased, right? The configuration is now higher in terms of what I'm trying to simulate. So this is what is there in terms of your analysis. So if we go and look at the example 5, and now if we run it, we'll be able to understand very well that what is happening. Now till this particular point, all the initialization has been done, and you can see there are two data centers and there are two data center brokers. The data center 1 and 2 both ask for the resources, both get the resources, right? And both of the brokers can send the request to one single data center as well. So you can look into this. So then we can see that there is a VM failure that has been happening for the first request, right? So broker 1 VM 0 has been created, whereas for broker 2 the VM creation has been failed, right? And similarly, you can see that the further executions are being done correspondingly for both the brokers on both the data centers, and the results are being printed correspondingly. So this is what you have in terms of two brokers, right? And then further, if you go on example 6 and try to see, okay, I was printing one thing over here. I believe that is with respect to the cloudlet list. Let me delete that, because if I run it, it will show you a huge log. Okay, once we are initializing, after initializing, it has been displaying before this. So I think that is going to be here in main method. Printing. I don't know where I was printing. Okay, so I was printing the log over here. If I delete this log, I should be able to reduce it. Great. So you can see the log here. So we are starting with the log, and then we start building up the infrastructure. So we are trying to create the virtual machine. Both the virtual machines have been created over the host, and then you can see that the cloudlets are being moved, are being submitted to particular set of virtual machines, right? And then they are being received at a particular point of time. Now there is another thing which which you might get in kind of confusing, is that every broker, every task has been displaying the same set of time, right? Same set of simulation time. This is because your virtual machine is running a time shared scheduler. So I've already explained this in last video, last webinar. So if I change it to the space, you will find that there will be a different receiving time corresponding to all the set of tasks. So there will be a batch corresponding to all the tasks. So this batch is running in one flow, and then further four are running in another flow. So the tasks are running in the set of four cloudlet batches, right? So this is how you can actually go and interpret your log, that how the changes which you are doing in your code, you can interpret correspondingly, right? So this is the very first part which you should be able to appreciate in terms of what changes you are doing to the system, right? And once you go through this particular part, and once you go back and see that, okay, what is the output right now? Now everything is working fine. I've gone through the log. I have seen everything, that everything is working fine as per what I was expecting. Now let's look at what my tasks are doing, right? Because at the end of the because at the end of the day, what you have to do is you have to do some analysis, right? In case if I have submitted some particular set of workload to the simulated configuration, then what is the basic output I have? So by default, there are a couple of things which are there. Generally, when you are working on task scheduling, or let's say VM migration and all that stuff, so you are actually looking at these kind of parameters. So submission time is one which is there if you are working on a deadline based system. Time spent under execution on computer device, that is another parameter which you look at. Wall clock time is one, that is actually resembling that when the task was submitted, and when it is actually being executed. In between, what time has been spent on what, it has not been considered, but wall clock time is time between the submission and the time at what its execution is over. Then there is waiting time. So wall clock time is basically the time spent under execution plus waiting time since the time of the submission, right? So that is what you have. Then you need to calculate that, okay, I'm running this particular workload on this particular simulated configuration. Then what is the CPU cost and the bandwidth cost we have, right? So that is another important parameter you actually go and look at. And other is all the compute resources where the cloudlet has been executed. If you are working on moving the cloudlet between the computing resources, so you might move one cloudlet between data center 0 and data center 1 and so on. So you have to do you have to work around the process event method where you are going to do the cloudlet move event, right? So that is what you have. So what are the different parameters that we can go and look into our example? So uh, point comes is that where you're going to do the changes corresponding to your output display. So again, within example Cloudsim example one I'm taking, within Cloudsim example one, the last step which I say, print the cloudlet list. This is where you should be able to do all the changes, because after execution, whatever the cloudlets are being received through the broker, like broker is going to give you back the list on the basis of what is the status of that particular workload. So that is being printed through this particular print cloudlet list method. So if you go inside this particular cloudlet method, you can simply see that it is working around only the cloudlet instance, right? So here, one advice, before you actually go and play around with this particular function or method, you should go and study the class cloudlet, which is available under the org.cloudburst.cloudsim. Right now, why I'm saying you should study the class, you should know that what parameters are available within this particular class, which we have already discussed in our previous webinars if you have attended it, or otherwise also the explanation is available on my course as well, which is available on superbitsacademy.online. So here you have to understand all the different set of parameters. You should know that, okay, which parameter does what for me. So if we take an example now we actually talk about all these parameters. So if we go and look at the parameters which are there, the attributes which are there inside the class, you can see there is a finish time, you can see there is execution start time, you can see there is resource list, right? And then you can see there is status which is being provided. Okay, you can see cost per bandwidth, accumulated bandwidth cost, right? And then you can also see last time we did delay. If you wanted to display all these things, you can also show that. So all these parameters are available now. Because they all are private, you cannot use them directly. So what this particular class is implementing is get and set methods, right? So there are a couple of get methods which you can use directly, right? So there is get cloudlet file size, there is get finished cloudlet finished so far, then cloudlet history, then cloudlet length, output size, status. All those methods are available, and you can utilize these methods for printing inside your Cloudsim example one. Few parameters can be directly called in, and few are supposed to be calculated manually. So let's say if I wanted to see when this particular task was submitted. So right now, if you see if you look at the console output, what you see is sorry, let me do this again. Yeah. So what you can see is you have a cloudlet ID, you have a status, you have a data center ID, you have a virtual machine ID, then time. Time is basically what is the execution time it has. Then you have start time, and then you have finish time. Okay. So start time and finish time we know. So if I wanted to see that, okay, what is the submitted time submitted, right? So what I can do is I can simply have a copy and then paste over here, and we can say submission time. Okay, now if I say submission time here, so that means I also need to print the submission time correspondingly. So I can have a get thing, get submission time, right? So this is here, the method is available here, get submission time is being provided. So if I run this particular example now, you can see the submission time is over here, that is 0.1. Okay, so the another entry has been added to this. So if you want, you can simply add more indentation so that it should be displayed properly. So here it is. So your submission time is 0.1. Now, if you wanted to see that, okay, what is the wall clock time which is there, right? So if I say wall clock time, let me embed this here only so that we should be able to do both the things together. So if I wanted to have a wall clock time, then that means I need to have another copy here, and I need to have get wall clock time to be printed, and then I can simply add more to it, right? This is the simplest thing, right? But because we are not aware about what is happening, what is available inside our API, we are not able to use that particular part. Wall clock time. And when I was studying this for my master thesis, I almost spent 3 months to understand all these things, which I'm giving you out in a couple of webinars or through my courses or through my YouTube videos. So if I run it again, you can see the wall clock time which has been spent into this particular simulation is 40. Now here I wanted to do one small trick. So let me take you to the another example, right? I'll copy these things, not another example, example 6, right? Because this is only one single cloudlet, so you will not be able to see much difference into this. So I take you to the print method, right? So this is the print method I have, and then I'll be copying these things, right? So these two parameters I'm going to copy in my another example, right? So I'll be quite quick in this. Yeah, and here I'll be taking these two things, and then I'm going to paste them inside here, right? So if I run this particular Cloudsim example 6, now you can see that what is the time, what is the submission time for that particular task, right? And what is the wall clock time? So wall clock time is the time spent in the waiting plus time spent during the execution and the total time that has been done. So if you see, all the tasks were being submitted. So from here, the task submission has been started. So all the tasks were submitted at 0.1 clock time, right? So we had 100 tasks to be executed through the virtual machine. So there were two virtual machines, VM0 and VM1, to which equally the tasks are being divided. Now, if we see what cloudlet scheduler they are using, so virtual machines are basically using the cloudlet. Let me go to the create VM. So you can see the space shared cloudlet scheduler space shared method has been used here. So this is the reason why the first set of cloudlets were spending only 10 wall clock time for the particular part, because there were two processing elements into this. Let me take you to the create data center. So you can see there are how many processing elements we have. All right, so we have 19 processing elements for my first set of host, and the another set of host we also having the same. So this is the reason why these virtual machines are there, because virtual machine only asks for the one processing element. So it is fully using that particular, sorry, two processing elements. So that is why it is using the two cores, right? So the wall clock time is corresponding to that. So these are some of the configuration changes which we did in our previous webinar. But yes, if we know all these things, then we are able to analyze that, okay, what is my output which has been happening. So for these two tasks, and for VM0 the wall clock time is 10, and for these two tasks again the wall clock time is 10. So that means for the very first unit of time, these 4 tasks were being executed, and for the next unit of time the another 4 tasks has been executed. Now because they were in the space shared policy, so while these first 4 tasks are being under execution, they were waiting, right? And same happens for the next set of batches, right? All the subsequent set of batches. So we have we have each batch of 4 cloudlets. So that means 100 divided by 4 is what we get in terms of our in a total batches. So we have 50 around 50 batches. So that is 250, sorry, 25 batches. So that means 250 is the maximum wall clock time which is there corresponding to that particular batch, right? The last set of four tasks are going to have 250 wall clock time. So that means they have spent around 240 unit of time in waiting, right? So if you are going to do the analysis corresponding to that, so what you can do is you can simply go and print that how much time they have spent in waiting, and that can be done in I believe there is a method which is there to print the wait time corresponding to a particular task. So let me delete this wall clock cloudlet wait. So we doesn't have this particular parameter wait time. So what we can do is we can do this get wall clock time, because we wanted to see how much time it has spent in under the waiting, and we also can use this particular parameter, that is summation time, right? uh, and we are also going to do a minus of how much time it has spent under the execution. Okay, so once we have all these parameters, we can actually see that at the last parameter that we wanted to print is the time spent in wait time. Okay, so I've added one parameter to this. So this is the, I think I did some mistake. Submission time minus, oh, so not submission time. We know how much, because wall clock time contains the submission time as well. So let me do this again. Oh my God, wait time. So is there anything, get execution time, get wall clock time? What is execution time? That is 10. Okay, so I think there is some sort of error we did. 9.1, 9.9, 9.9, 9.9. So submission time, start time. Execution start time. Oh, it's not execution start time, it's the get actual CPU time. Right. I'm very sorry for confusion. So it's a get actual CPU time. And once you have this actual CPU time, you can actually see. So actual CPU time is how much time you have spent during that particular execution. So this, once you subtract this time from the wall clock time, you will be able to get this particular parameter. So that is what you get in terms of your subsequent step of printing more parameters into your final report, and then you can generate, once you have all these things, you can save them into Excel file or CSV file, and then you can actually go and create your charts. So this is I hope is clear, right, that how things are happening within this particular printing part. So there is one more parameter I wanted to mention here, is that is the cost which should be uh, you know applicable in terms of execution of that particular cloud rest, because most of the time you also go and look into the optimization of the task that you are doing, optimization of the cost that you are doing. So that can also be done by there is a parameter which has been available, right? And if I take you to the cloudlet, the total cost which is there is corresponding to the execution time, that there is a cost per CPU, I think. So cost per second is this method is there, which is going to get you the total cost which has been spent while executing that particular task on the simulation. So for that particular part, what you can simply do is you can simply go and uh, get the CPU cost per second, right? So this is what you get, and once I execute this, you can see how much cost has been there. So every task has been, taking the same amount of time, because these are the homogeneous tasks which we have. All the cloudlets have the same configuration. So if we have different, we will be able to, you know, get the different set of values here. Now, from where this 3 comes out. So for this, you should go to create data center, right? And within this create data center, you can go to the data center characteristics. You can see 3 here, right? 3 is quite high in terms of US cost. So let's say per CPU, per second CPU time, we may charge 0.3, right? And once I have this particular value, you can see what value I'm going to get corresponding to my CPU time. Now, same you can go for the bandwidth as well. So for bandwidth, right now, if you look at the bandwidth is 0.1, right? But if you go and see what is the method which has been available for the bandwidth, you will not be able to find any. So get bandwidth, there is no get bandwidth method over here. So, but we know that we have a accumulated bandwidth parameter, right? So let me take you to the attributes or variables of this particular class, cloudlet class. So you can see there is where is it? Where is it? Accumulated bandwidth. Yeah. So this is the accumulated bandwidth cost we have, right? This is protected. That means we cannot use it directly. So what I do is I just go to some no get method. Let me go to CPU per sec, right? So instead of having this, I'm going to write a new method here, public. I think accumulated bandwidth is of type public double get BW, and that's it. Okay, and here I can return. So just I'm creating the simplest get method. So let me just double check. Okay, great. It's double return type, so we have a match. So once I create this particular method, so I'm telling you how you can change the class as well, or extend the class as well. And once I have it, I can go back to my print method, right? And I can just simply have another value added to it. And here, what I can do is I can have a get BW, right? So once I add this particular thing over here, you can simply have your bandwidth value. So this is the bandwidth what you get in terms of your total terms, right? So when how do I know that this is 3000 or something, right? So we have to go to our cloudlets first, because bandwidth is basically network based bandwidth, right? So once we go and look at the cloudlet, what is the file size we have? The file size which we have is 30,000 file size is going to be sent from the task to the system, right? So this is the input cost which we have, accumulated bandwidth, and this is the output cost that we are considering. So accumulated cost, if you go and look inside the data center, once the resources are being allocated, the cost which is being calculated is only based on what is the file size in the input, right? So I'm just telling you, I'm just giving you an idea that we have a small bug inside this particular Cloudsim, that they have not took care of one another parameter. So let me just take you here, set set resource parameters, right? So within the resource parameter, you can see the accumulated cost is being calculated on the basis of get cloudlet file size, right? And this get cloudlet file size is basically only the input file size they have. Okay, whereas the total amount which is been done for each task is this get cloudlet plus I hope there is a method. I haven't seen this. Plus cloudlet output size, right? So this is what is the actual value which it should return. So once we have this thing, and if I go back and run it again for you, you can see this is the total cost which happens corresponding to your bandwidth in a particular task, right? So this is how you can actually calculate in terms of your network bandwidth as well, network cost. So this cost plus this cost. Now, again, this is quite high in terms of what you have for your actual cloud-based system. So you can go to the data center, and then you can go to the bandwidth cost, and you can make it a more cheaper. Okay, bandwidth per second. So once we go and run this again, you can see what your cost is now. Your cost is around 80 US dollars, right, for one particular task. So I'm just considering that it's US dollars. If it is rupees, it's quite cheap. So that is how you can actually go and work around. Now, one thing I want to mention, that there is no cost per storage, no cost per memory is being provided in Cloudlet, right? There is no parameter you will find corresponding to it. So if you wanted to add it, you have to add the attribute, and then you have to go and print correspondingly. So this is quite important in terms of if you are extensively looking at the different kind of parameters while simulating your workload on a particular simulation scenario, right? So this is what you have correspondingly for your first step of actually understanding the overall console based log, and how you can change it, extend it as per your requirement, right? So I hope this makes some sense. In case like in case if it is through with you, I wanted to see some no something in my chat window right now. So I hope everyone is following what we are trying to learn here. So is there any clock function in the code for execution time calculation, and by using that can we stop the execution and will add delay? That I'm going to come in some time. Okay, great. So there are only 4 yeses, so I think for rest of it is going above. I want to see, I want to hear from everyone. So yes, latency will be added, a delay. Yes, we can add the delay, no problem in that. But very hard to remember all things. No worries, Rupinder. The recording will be available as usual. I send all the recordings uh, to all the participants who actually attend the webinar. So you will definitely get it. So don't worry about it. It is something which is very hard to remember. You will get the recording of this particular session definitely. If you have already subscribed to the course, you will get in that course. If you are attending right now, you will get in your email box. That is what I have provisions for you. So anyways, this is what you can have for your set of part. And there is one question which is corresponding to the delay, right? And yes, of course, a practice is very important. No issues. You cannot compromise on practice. Obviously, if you are doing your research on your own, you have to do practice definitely. Let me quickly just go through the delay part. So we know we have a delay parameter within our what do you call data center broker. So let me go to the data center broker. Let me take you to the submit cloudlet method, right? And within the submit cloudlet method, we have this send method with a delay added to it, right? So if we wanted to have a delay, we can have a random delay correspondingly if we wanted to have some kind of delay here. So what I can do is, because previously we changed it, I'm just going to simply have a random thing. So new random, we just created the instance, and next int, and we bound it for 1000, right? Now if I add a delay, now this is one simple change which we can do for adding a delay to the submission of your cloudlet. And this has been done inside the data center broker class, and there is a method named as submit cloudlet, right? So I'm just repeating it again if you are attending my session for the first time. So if I go back and run my example one again, you can see now there is a difference in every individual parameter that has been happening. So your time of execution will be same, but your start time will be different. And same happens over here when the brokers are being received back, right? They all were submitted at one point of time, but there has been delay added to each of them, and all because of that the execution is delayed, and their receiving is also delayed now. Okay, and once their receiving is delayed, you can see there is a finish time which is different. There is a submission time which is there at a different point of time. There is a wall clock time. There is a difference in wall clock time that is happening, right? And there is a wait time which is happening corresponding to each set of cloudlet, and so on, right? So this is how you can actually, go and put in the delay corresponding to your system. So that was quite quick in terms of implementing your work. So execution of tasks is also dependent on RAM. Can you please highlight on it? Of course, it no, exactly. If I tell you, the RAM is basically dependent on the VM, right? Not other things. How can we trade off between 2 to 3? I've just only shown you that how we can trade off between the things. That is basically a scope of the scheduling part. But right now, for that you can watch my previous webinar on task scheduling. So you can actually go and look into the parameter corresponding to that particular thing, right? And let me we are still on the very first agenda, so we have to be quick. This is Sunday night, everyone wants to sleep, so I wanted to finish it max by 10:30. I hope you will also be looking into that. You will also be interested in that. So till now we know what is the console, right? Output, and what is the status of the cloudlets that we have, and what we can generate correspondingly, right? Give me a sec, I need to just switch off my no. I was just running my blower, and it's quite hot now. Anyways, so we have covered our first point. Now let's go to the next point. Right. So observing the multiple results in the simulation, that is very important, because generally what happens is you have to do the comparisons, right? Now, once you have to do the comparisons in that particular sense, what you need to do is, let's say I'm running a particular algorithm for a certain set of configurations of virtual machine, number of virtual machines, right? So if I wanted to have that particular part, so maybe if we see here, what is happening is, like, let me take you to the example here. Yeah. So within main method, yeah, here it is. So within main method, if we look at these two lines, what is happening is we are running the virtual machine uh, for two virtual machines, and there are 100 tasks we are executing, right? Let's say I wanted to see that what is the make span time. Now, I hope make span time, make span time is the total time which is spent on a complete batch of tasks during a particular simulation run, right? So that is what make span is. So you wanted to see that what is the difference between the make span time if you increase or decrease the number of virtual machines, right? So there is like, for one virtual machine, maybe if I to make it straightforward, I need to remove this delay first, so that we should not be able to get some random results correspondingly. Yeah, so the submission is at the same time, return is this. Great. Right, so now I'm confirmed that everything is fine. So we have two virtual machines, right? And we have 100 cloudlets to be executed. So I wanted to see that if I run the simulation from one virtual machine to 5 virtual machine, what is the difference? So one way is, I just change this to 1, I run it, I keep a note of the final execution. So final execution basically happens at 500.1, right? So first, with one VM, it is 500.1. For two VMs, it is going to be, the final time is 250.1. With three VMs, what is happening is, with three VMs, the time is around 170, the make span for this particular batch. And with four is the time span which I'm going make span which I'm going to have 130, and with 5 is this, right? So with 5 I'm having 100. So I know I've reduced the make span from 500 to 100, right? So when I say make span, that means what is the time when the last cloudlet or task has been finished, right? So that's my make span. So from 500, we have reduced it to 100, right? So we were able to see the optimization in terms of my make span, right? But I had to do it manually. So till 5, it was okay, right? I could able to change even for 6, 7, 10 also I can do it. But what if I wanted to check for hundreds of different kind of scenarios, right? So that is not possible for us. So what we can do is this can be automated as well. You can do the iteration corresponding to each set of parameters. So if you wanted to have multiple parameters, you can have multiple no nested iterations correspondingly. So what I'm going to show you is the simplest one. So because I wanted to test it for number of virtual machines, so what I can do is I can do it as for int vm loop, right? Maybe I say simply say loop count, so that I should be able to quickly IntelliSense it. Count starting from 1, right? I wanted to take this loop count to, let's say, less than or equal to 10, and then loop count should be incremented by 1, right? That is what I have. So this is one thing I can do. And here what I'm going to do is I'm going to embed all this particular logic of main inside the iteration, single iteration which I wanted to have. And instead of going for the manual entry, I'm just going to have a loop count, and I can have multiple virtual machine running into it. Now, just to do a quick printing, I'm just going to have a 20 cloudlets right now. We can increase it to any number of cloudlets as you have already seen. So if you see, there has been multiple iterations which has been done now, and they were quick. So I don't know which iteration it is, right? So just to have a log for that, so I'm going to have so maybe stars I put in between somewhere. I say iteration number is, so if you are fluent with Java, I think you understand it well. So if I run this now, you can see I know which iteration it is into and what results it is printing. So iteration 1, right? Within iteration 1, everything is happening. All the cloudlets are being submitted. And then we know that for one single virtual machine, there is 100 make span time. And then for second iteration, it's 50 make span time. Still, we are doing it manually. Then for 3 virtual machines, it is 40 make span time. And then if we look at fourth iteration, it's 30. For fifth iteration, it's 20. For sixth iteration, it's 20 again. Seventh iteration, 20 again. So that means after this, the improvement has stalled, right? Because your number of VMs are, I think, more, and all that stuff. So this is what you have in terms of your multiple iterations which you can run correspondingly. So that means whatever the configuration you have chosen, after 6 iteration there is no change. So that is the maximum time to what you can actually go and optimize it, right? So that is what I wanted to tell you in this slide, that run the simulation with different configuration and record the results. That is manually, or be smart, run a loop, right? Run a loop for either single parameter or multiple parameters. So maybe you wanted to have different cloudlets correspondingly. So maybe I say that there is a first iteration of VM, iteration number for, let's say, VM, right? Whereas if I wanted to have another nested loop, I can have a loop for what? I can have a loop for, let's say, loop cloudlet loop, and here again, and here again. Now instead of I do not want to have it from like +1. I wanted to have cloudlet loop equals to cloudlet maybe plus and 20. So with the difference of 20, I wanted to see what could be the possible change that is going to be there, and I just need to fulfill this structure, this block, and here we are. And this cloudlet loop can be put into this, right? And once we execute it, now this will run for how many number of times, like up to here, let's say I make it 4, and here we have made 5 iterations, right? Because 20 jump of 20 is done here. So when we have jump of 20, so that means 5 into 4, 20 iterations will run into this particular part. So if we run this, you can actually see there are number of iterations which are happening correspondingly each of the scheme. So it's up to you how many number of times, because the console has a very limited buffer, so only last 2 iterations were displayed. So if it is smaller, so maybe if I make it more smaller, maybe I make it 10 only, with a difference of 2, right? Then you will be able to see that what is a log. So all the logs are being printed correspondingly, and you can actually see that for each individual virtual machine. So VM1, when we have one virtual machine, one task, this is the first make span. If we have more tasks, this is another make span, more task, another make span, more task, another make span. So this is for only first single virtual machine. And then if we see 2 virtual machines, then we have this, another is 10, 20. So there is an improvement which you can show in your paper, right? This is a very vague sample which I'm displaying you, but you can think about your scenarios as well, right? So this is what you get in terms of your number of iterations, what you can have correspondingly. So let me simplify it again, and I'm going to remove this loop, right? So it's up to you how much you wanted to make it nested. As much as nested you are going to make it, this is going to get complicated. So it's up to you that how you are going to take care of this particular part. Now next comes is, and the most important part is, that how we are going to generate the reports, right? I cannot do everything manual, so this is what you can use. This is a small piece of code which we can use corresponding to our individual work. So file writer is a class which helps you to do this correspondingly. So it's quite simple. We are going to write a CSV in terms of our particular code. So this I'm going to record only one parameter, 2 parameters here. One parameter I'm going to record is the number of VMs, and the second parameter I'm going to record is the make span, right? So that is what sample I've created for you. Okay, so let me quickly come to this particular place, because we wanted to have a log, right? So what we can do is I can have a, so what's the file? It's a file writer. Maybe we can have any name. So maybe test or write to file, right? That is what is there. And now, because this is something which is going to happen through IO, right? So we need to have a IO exception. That is the reason we have written a try. I've not pasted the complete code block over here, but yes, we need to have this try catch statement corresponding to it. And right now we have not instantiated any of the things. So by default, latest Eclipse IDE is going to import it automatically. Right now I have to import it. I've just hovered it and imported. So next is, because I need to have try against it, or maybe we generate it. So write to file equals to, so maybe I create a file, right? So whatever the title you wanted to have, D, I'm going to put it in D drive. Maybe I give it a name, makespan.csv, right? And that is what I have. Okay, and then what we can do is, because I need to have titles correspondingly, that is what I have done over here. csv writer dot append, and within the brackets I've given the name of that particular column. So we can write it at write to file dot append, right? And within that I can say vm count. Okay. And then again what we can do is, because we need to have this comma separated, and then again I can have the second part, that is make span, right? And in case if you want to put a new line after this, so this is a new line because this is csv, right? So you write line by line. So that has been done inside the particular uh, csv. Now csv is open right now. If once we create the instance, the csv is already created and open. If it is not already open on the system, everything will go fine. And then next thing is, because I wanted to have a particular value corresponding to my system, so what I'm going to have is just before getting on to the print, right? Because I have to do it for every individual run. So the logic which is going to be here is, because I'm writing this before, and then the loop is going to for every individual virtual machine. Yes, that's okay. So what we are going to do is, I'm going to have write vm instead of vm count. What I'm going to do is, I'm going to have a loop count here, right? Because append is basically going to have a string parameter. So we have to do typecasting integer. Oh my God. Integer dot toString, right? And within this loop count will be added, so that I know what is the configuration of my VM count right now. And whereas instead of make span, now I know whatever the time of my last task which has been submitted, that is going to be there. So here it is going to be because the cloudlet list is received in new list, so that means I'm going to have new list dot get. I'm going to get a last index, right? So last index, what I can get is new list dot size, because the index is 0 base, so -1. So now I have the last cloudlet. So here I wanted to have the time at what it has been received, right? So the time at what it has been received should be the wall clock time, right? So that wall clock time is going to be, wall clock time get wall clock time. That is what I have correspondingly. Now again, because append is a string, so we need to have this thing converted. So to convert this, what we are going to have is it should be in this print. This is going to give me what double value, right? So double dot toString, right? And this typecasting is to be done correspondingly. Now before doing this, I just wanted to do a round of this particular thing. So mat dot round double, right? Now why I did this, so that I should have a rounded value corresponding to my final make span, so that I should be able to do the printing correspondingly. And now once everything is done, we have to flush, and we have to close the we have to flush the buffer first, and then we have to close the file writer instance, right? So write to file, that is supposed to be flushed just after this particular loop. Once everything is over, this dot flush and this dot close. So if you know how file handling is working, this is how it has been done. So I hope, as per what logic I have built, it should work better. So this loop is not going to be there. So 40. Great. So I think there is some error. I think we need to put it in, try catch. So here what I can do is I can do a corresponding generation. Show me, so surrounded by try catch. So this is what I'm going to have it over here. All right. So I did nothing. I just matched the blocks. That's it. Code blocks, right? And this is supposed to be done because this is going to generate an IO error if things are not going to work fine. And we need to catch that exception so that my program doesn't halt uh, in between, right? So everything is done. I hope, fingers crossed, everything should work fine. Otherwise, it's like a very bad impression on live session. Anyways, let's go to the D drive. Great. I go to my D drive and let's see if we have makespan. Yeah, we have a makespan file, and you can see we have all those values over here. So VM count, the first makespan is 200, then 100, then 70, and then 50. So what I can do is I can just choose these values. I can go to insert, I can go to generate my things. So this is how you can actually generate correspondingly. So your VM count and correspond. Oh, no. I think I made some mistake and I've created two different layouts. So this is simple. Yeah, this simple should be no. This is simple. More chart columns. So this is how you can resemble. So maybe with this. So this is what my makespan is, corresponding to one VM, two VMs, three VMs, and four VMs. So we can clearly represent that with each particular set of virtual machine increase in the configuration, we have a better makespan time and we have an optimized result correspondingly. So this is one of the simplest example which you can have corresponding to your work. So maybe I can run this particular part for you. So maybe we change the makespan 1. We increase the number of cloudlets to, let's say, 100, right? And then we increase the number of virtual machines to, let's say, 10 again, right? So here, once I go and create for you, so result is being, no, normal log is there, but within my D drive, you can see there is a makespan, and that makespan is being displayed, and this is corresponding to my 10 virtual machines. And when I go to insert, I can get to all these values more, and then I can click on this, and this is what I get. So I can simply see from the chart that after after 7, after virtual machine 8, the result is consistent, and this is because my underlying host configurations are not going to support it. If they support it, then things will go differently. And this is happening when it is time shared, right? What if I wanted to have for other part, and that is for space shared policy was used in virtual machines. So if I wanted to change it to the where it is, create VM, if I change it to the time shared, right? So if it is time shared, and if I go and change my makespan 1 to underscore time shared, just to have a resemblance, I'm keeping it simple. I can also go and create the same file for both of these things. So if I go to my D drive, I have makespan for my things. So this is another makespan I get. So what I can do is I can just copy this makespan, right? I can go back here. I can print this over here. So this is for time shared. This is for space shared, right? And I can delete this particular chart, and I can just select this. I can have my insert. Now I can just simply go and print the value, more columns, and this is what is there. So you can clearly see there is some change in the 6th value after the number of virtual machines which are being increased uh, at some point of time. Like this is where the changes happening. This is where the change is happening. And after this, the change is happening. So point 0.5 has been there, the difference, and this is how you can resemble it inside your particular chart. So I think this is the simplest way how you can actually go and uh, represent your results in the Excel file. But basically, it's CSV which you can open by using Microsoft Excel, and then you can actually go and you know uh, copy this. Just go to your WinWord, or maybe your text file. Just go there, paste it, and just do the stuff correspondingly. So I think that this is how you can actually make things work for yourself. And uh, overall, the printing can be done correspondingly in this particular set. I think let's go. Yeah. So this is where I think I should stop. It's almost 10:30. So now if you have any queries, you are free to ask them. Let me just give you all the rights. You can unmute yourself. You can type in chat wherever you feel better. Okay, so there are a few queries I think I missed. So let me do check it from the start. I just go through the chat first. So we have devoted time for recording. It's time for. So I have one request that we are devoting time. Can we have recordings for all? We all are devoting time, ma'am. Definitely. We will have our recording later on. Sorry for. Are these specific methods within the data center broker class and other classes going to be discussed about? Ahmed, today they were not. In previous webinars, we have already done that. You can download it through some links. I can mention it later on. It's basically available on events.superwitsacademy.online/task scheduling webinar, and there is one more large simulation webinar. So that is what I have. Then with this material be sent to participants. Recording I'm going to send. Thank you very much, Professor, for the knowledge share. Though I had problem joining at the beginning of the class, can you please give me permission to record that? George, I've already said recording will be there. Then Sumit says, sir, is there any clock function in the code for execution time? Calculating by using that we can stop the execution. Yes, you can. You can terminate the simulation, but that will be abrupt termination. So that you need to take care of. So wherever you wanted to stop it, Cloudsim dot terminate simulation. That is the method which we can use. Lakshmi was asking, latency will add delay, right? Yes, definitely it will add delay to it. Then Nazir can understand, but remembering is difficult. No problem. Recording will be provided. Dr. Binda, yes. More time devotion, yes, definitely it will be. Bindu, I will be coming to you once I go through the chat. How we can trade off between 2 or 3 parameters in the task scheduling. So 2 or 3 parameters, you can choose it. As I said, like right now, what parameters I have used is 3 parameters I have represented. One is make span, one is changing the virtual machine count and changing the cloudlet. So whatever the number of parameters you wanted to change, you can do it either in the example itself, or you can do it the changes in the submit cloudlet method of data center broker. Can you please share something about the energy efficiency? It's in Nazir. It's in my schedule. I will be doing one webinar on that. Execution of the task is also dependent on RAM. No, can you please highlight on it? I've already discussed about it. VM is what is going to have the resemblance, but RAM is not. Then thank you, sir. In the stop execution at any point is possible. Sumit, I've already answered this. Sir, your iFox CMS course is now not visible on Udemy. Sumit, there are some challenges on Udemy. I've stopped it. I've actually removed it from the Udemy. You can join this course on superwitsacademy.online. That is where it is hosting right now. Can we compute energy efficiency here? Not in the simple examples. If you are running the Planet Lab examples, definitely yes, you can do. Then comes is it is requested to please conduct a webinar on iFoxim. Mazhar, I'm going to do it. It's in maybe next week or next to next week. Thank you. Things become clear to me. Yes, we please send the webinar link on recording. Yes, it will be there. How we can calculate load balancing and energy consumption parameters. Jeshwari, this is going to be in the next session. Uh, Maybe next or next to next, depending upon how much time do I require to put it as a session, because if I start discussing the things, it sometime it becomes lengthy, so I want to make it more precise. So it will take some time, but yes, definitely I'm going to talk about this particular part where you have asked for that, how to calculate the load balancing and energy consumption parameters, right? Then Bindu asks, sir, can we use Cloudsim for data security? Bindu, yes, we can use, but you have to do a lot of work into this. You need to understand that Cloudsim is basically a building up of models, right? So data center broker is basically a model class which is going to do the similar behavior as the real cloud data center broker does. So if you wanted to have a data security implementation, you have to do all those behavior implementations as a simple entity inside the Cloudsim, and then you can work it out. If you wanted to look into it, there is one GitHub repository corresponding to it. I'm not able to recall the name of the user, but yes, it is there. So you can actually go and look at Cloudsim security. So maybe you can find, it's not official, somebody has worked on it and they have put that repository out there. Okay. Yeah, nice session. Thank you. And Nazir, thank you, sir. Thank you, Nazir. So Mazhar says, is it possible if you conduct a seminar for our cloud computing student, they may also interested in the Cloudsim course. So Mazhar, you can send me a request on my email address. You have my email address, right? hello@superwits.com. We can conversate on that corresponding to this. May says, thank you, sir. Please share the record video. Yes, definitely. It will be there. Nadeem, how can we use some real-time workload like NASA workload or HPCN2? Nadeem ji, in I think in last session, I spoke about this. If you missed it, you can go through that. Last and in fact in both the sessions, I spoke about it, that how you can actually go and implement this particular part and during the question answer time. So you can go through that particular video. So just to mention one very specific thing, any workload which you wanted to integrate, only compute can be integrated by default, because you have to mention that particular part. Whereas if you wanted to have more than compute, maybe RAM or maybe bandwidth, then you have to do a lot of work, a lot of custom integration of code into that, right? So there is a Planet Lab helper class which we have to use. Then Usher says, please conduct one webinar on energy efficiency. Definitely we do that. Dr. Pinder says, I need machine learning help also. Please do some webinar on that. We need to see how we can get this into our schedule. I want to join coming webinars also. May I send emails, right? So if you are on the newsletter, so definitely you are going to get the link. And this is I think for this webinar also you got the email, so you can definitely attend to those specific webinars, because everyone has their own interest, right? So some has interest in task scheduling, some has interest in today's session like generating the report, some has interest in something else. So whatever your interest, as per that you can come and register to this thing. Yogita, thank you, sir. Nadeem, Jesus, thank you, sir. It's my pleasure, Yogita and Nadeem. Then Lakshmi asks about CPU, IO, and storage are the three parameters in IaaS, but Cloudsim we calculate only CPU utilization, right? Perfectly right. The more stress is on CPU, right? If you wanted to calculate other things like network, you have to that if you go and look around the code, you will find that data center has been extended into two different variants. One is the network based data center and second is the power data center. So if you are working on power aware thing, you should be using power data center. And when you are using power data center, at that point of time, CPU is only one parameter which is there. Whereas if you go and use the network, then the IO is going to help you out in that network based IO. For storage, you have to integrate the file related complete what do you call API. So there are some changes you have to do. So for that, you need to have an understanding of the complete API. So if you are already working on it and you know what particular component fits where, that's great. You can follow it. Otherwise, the purpose why I've created the essential cloud sim tutorial course on superwitsacademy.online is this only. I told you that I've spent 3 or 3.5 months for understanding the code itself. Whereas if you go through my course, it will hardly take you maybe 2 weeks if you go through all the videos, and you will be able to appreciate all the API things, and you will be able to connect all the dots. And then there comes the power to you, that how you can manipulate the complete API for your work. So that is the primary purpose of that course, because I cannot devote my time with everyone, right? So the reason I've made that course is this, that uh, all should have access without the delay, right? And the cost which I have put into that is basically goes to the hosting, right? Because the LMS is quite costly, which I'm using, right? So because otherwise, if I put it on website on, so not of that particular quality of in terms of delivery. So that is the reason the cost has been associated to that particular course. Then Dr. Upinder says, thank you, Upinder. This is my pleasure. And Asha says, thank you. Then Rajeshwari is asking for workflow scheduling. This is also there. I'm going to publish my schedule, because when I was going through the the challenges which were being submitted to the Google form, which I've shared with you, there were a couple of points which were highlighted. One is workflow scheduling. One is this, like the topic which we covered today. One is on the iFoxim. One is on the cloud analyst, right? One is on one point is on the virtual machine migrations and the power efficiency. So all those you know topics will be in the future. But definitely, you can also understand, I also work full time. So we all have to manage. So Sunday night 9 p.m. is only for this. So this is where when I connect with the community, and then we go through the things. So we are going to talk about all these topics, but it will take some time. Some patience is required. Nazir is saying, very useful session, sir. Thank you very much. Looking forward for sessions in futures. My pleasure, Nazir. Thank you very much for appreciation. Guneet, thank you. Thank you. Please publish it. Multi-objective optimization. Definitely we go for that. Today we touched upon few of the things, but maybe yes, we can, Rajeshwari, we can go through this multi-objective optimization, but we need to see how we are going to do it. Is it like some paper we need to review, and then we do this multi-objective optimization, or maybe some hypothetical concept we wanted to use? So it we'll see in future. uh Heather, thank you very much. Great, thank you. There's Lakshmi. Yes, sir. Course is fantastic. I took it and understood. As you said, within 2 weeks. Now I'm listening it again in detail with aim to. Yeah, definitely, Lakshmi. Sometimes you have to review these sessions again, because there is plenty of information out, and there some is to be used. Like, you may have 2 3 use cases, and there might be some couple of different set of classes which are used in each individual use case. So it depends upon your requirement. So I think once you go through that, you will be able to appreciate that particular fact. Then Rupali says, waiting for load balancing using various parameters. So I think, Rupali, your topic and Rajeshwari's topic is same, multi-objective optimization. So we'll try to cover in that. So that is where I think chats are over. So anyone who wants to speak, they can unmute their mic and video. I think from my side the session is over. And yes, there are a couple of resources which you can go through. There is www.cloudsimtutorials.online, which you can follow for articles. I'm not very frequent on writing articles on this, but whatever is available there is good to start for the readers who do not want to pay for the course. Then there is a www.superwitsacademy.online. This is where the courses are hosted. There are 3 courses which you can follow. If you are only interested in task scheduling, there is one separate course. If you wanted to have a complete understanding of iFogSim or Cloudsim, there are two separate courses for it. iFogSim is still under development. More is coming to it. I'll keep you posted when I update it, right? And there's something which I started just some time back. I just changed. It was already there, but I changed something on anupinder.com. You can follow me there as well. So you can. These are some of the resources where I generally post my relevant stuff. So whatever interests me, I post on these relevant platforms as per their applicability. So that is what I have for today's session. And uh, Jaws says, thank you so much for your time and knowledge sharing. I look forward to our next session. You are welcome, Jaws, and thank you very much for appreciation. Anyone who wants to speak, you can unmute your mic,
Okay,
and we have.
thank you
Go
so
ahead.
much, Prof, for the knowledge shared.
Uh,
May
just
God
thank you,
Almighty strengthen you.
thank you.
Uh,
Yes.
I pray that you have more time for us, especially those of us who are just very new in the use of Cloudsim for cloud simulation scenarios.
Mhm,
People like me, I'm very new to this area.
mhm.
And though I joined very late, but I enjoyed the lecture. And I believe that subsequent ones will assist us to harness this knowledge very well. Thank you so much,
So
Prof.
definitely, George, you're going to have once you go through all the content, it's huge, right? And you need to find out that okay, which content is relevant to you. So it may take some time, right? And as you go through the content, you will be able to connect the dots, and that is how every individual beginner is going to face. So that's not a problem. Just you need to be persistent with your practice alongside, right? That's very
It's all
important.
right, sir. Thank you
Yeah.
very much, sir. Thank you,
Right.
sir.
Thank you, Josh.
Yes, sir.
Yes. So Heather says if I pay for iFog later, I will be able to pay iCost. Heather, if there's any problem, just connect with me on hello@superwits.com, right? Uh, I'm just typing in hello@superwits.com. This is what is my email address. Uh, and other one is like if you wanted to connect with me, there is a Telegram channel and Superwits Academy for quick updates, right? So this is what you have. Yeah, I think you all guys are free to connect with each other. I think you can send direct messages to each other as well. If you want to connect, you want to create a community, that is very important, because this is a tool. When we are in community, we discuss, we talk about our experiences, that how we started with and what use case we are working on right now, and how somebody else can get a help from that. Of course, I can understand that it's very difficult for every one of you to share your research work, but maybe the broad idea that how different API components can be used for what purpose, right? Because generically, if you look at task scheduling is one domain, power computing is one domain, right? VM migration is one domain. You need not to discuss your ideas that what you are working on, but maybe you can discuss that how these tools work together, right? So you may exchange your email addresses, you may exchange your contact numbers as well, in case if you want. Maybe it's a public forum. Maybe you might be not sure to put it out. Maybe you can connect it through the Telegram channel, which is available on my side, right? So feel free to connect with each other, because once you have team, you have broad ideas, right? And you help each other to grow in terms of your overall knowledge of the tool. Because if you talk about the people who work on these tools throughout the research community, if there are very few, right? And even majority of them are reluctant to share their information, right? I don't know what stops them to do it, but anyways, yes. So my agenda for starting all this is that I know what pain you guys go through while doing the research, right? You have to read your paper, you have to, understand what is going to be there for your problem statement, and of course you have to go and work on the tool. So these three things work parallelly, and it mess up your mind sometimes. So it's up to you that how you want to connect with each other, right? And there is one very very specific request. If any one of you wants at any point of time, today or in future, if you want to contribute some content to Cloudsim tutorials.online platform, I am open for that, right? I have no issues. You can send a request and we can go through that particular part, right? So that's something which will help, which
Well,
will help
sir,
the community. Yeah, Mazhar, yes, go on.
well, sir, I am Nazar Bukhari. I want to say something.
Yes, Mazhar, please.
Hello.
Yes, I can hear. We all can hear you. You can go.
Uh,
Go ahead.
when
Yes.
when I joined this session,
Mhm.
this online session,
Mhm.
I was interested only in iFoxSim tutorial. But I believe we should do CloudSim course as well. My question is there any prerequisite to join this course so that we can first of all prepare ourselves, then we can register in this course? Would you please tell the prerequisite of CloudSim course?
So for like, if you know some object oriented programming, right? That's a very very single prerequisite which you should have, because if you go and look into the course, the very first lecture is talking about the basic cloud computing and how it connects with the cloud sim, right? So what's a gap between the cloud sim and the real world? I try to connect in the very first lecture. So if you have a basic understanding of cloud computing, very basic, and if you know how basic programming, object oriented programming system works, so if you are through with C++, it's very quick to, very easy and quick to jump onto Java, right? So you just only need to look into two data structures. One is array list and one is the hash maps or trees, right? So that is what you need to look into. And once you go through those two three data structures of Java, it's quite easy to jump onto this particular tool and start experimenting with it. So one suggestion from my side: whenever you go and start learning the concept about this uh, Cloudsim tool, right, or any of the extension tool, you should practice side by side, right? If you go through the lecture, if you go through some YouTube video, if you go through some article, read it, go into that particular specific file, make some changes to it, see what is just go and see what changes are been happening onto your particular console output, and that actually gives you a clarity of your concept that okay, this is what change I made to the particular code, and this is what is the response that is going to coming to the particular console output, or coming to the overall simulation. So that is very very important. Practice is something which if you follow, this is going to be cherry on the cake. If you learn about this tool, if you are trying to learn this tool, so that is very much important. The practice is something which you should never ever no, neglect.
And just like other participants have told that someone is interested in fault tolerance, someone is interested in load balancing, security, and so on.
Mhm.
Is there different examples so that we can pick one of them and customize that particular scenario?
So if you go through the examples, there are a couple of use cases they have already given. So the basic example API, the very first API which you see, there are 8 examples, right? And uh, if you start with the very first one, that is for the beginners. If you go to the eighth one, that is for someone who wants to run dynamic entities, right? So if you wanted to create a data center on the run on dynamically, that is what Cloudsim example 8 shows you. So similarly, when you move on to the next API, you will find in networks they have done something which is corresponding corresponding to creating topologies. right? And similarly for next, if you see, it's for the power aware. One is for the Planet Lab dataset and one is for the random dataset. And they have actually created around combination of 5 allocation virtual machine allocation algorithms and 4 virtual machine selection algorithms. So they have given you an overall no idea that how you can actually implement your work, right? So if you wanted to work on power aware implementations, and if you wanted to change any of the files, so maybe you can take iqr plus mmt file or iqr mmr file or iqr mt file, right? So it's up to you which file you wanted to change. So the point comes is you should know where the changes are supposed to be done, right? So in our task scheduling algorithm, for the basic one, uh, I've already shown you that how you can go and change the submit cloudlet method within the data center, and that is the simplest task allocation method or task allocation procedure, or you can say task to virtual machine mapping procedure for a single simple example, right? For a single use case, right? So similarly for power aware, you have to go and work inside the power VM allocation policy classes, right? So the point comes is that which particular component you want to work on, you should know which class is supporting it, and the examples are basically referring those classes, right? So whatever you write in the example, or if you copy the example and start changing it, you can simply change it if you go and change the actual class into that. So that is what I have actually explained in my course, in the Cloudsim course, right? So that is where that course helps you out in understanding that okay, this is the place where you should go and change in terms of a very specific use case.
Thank you. My last question. Thank you.
Yeah.
And all these examples and scenarios are built in with Cloudsim software, Cloudsim training program.
Not everyone, because every example, uh, like if you go and look at the examples which are in the power API, right? They are almost similar, right? There are very small changes that they are doing in that particular example, and you can actually go and appreciate it once you go through the code, right? So I've explained only one example, right, from the power, two or three examples from the basic one. There's no scenario which is related to the network, right? Because I didn't get a chance to record all those simulations. But once the need arises, we can do that as well. But till now, nobody requested for it, so it's not there. So examples are similar. So I took one single example, explained it, and you can use that explained example to work on the other examples as well. There is not much difference in them. I think that answered your query, I think.
And sir, for uh, within how much time we can complete that course? For example, we get admission tomorrow, and how many days or weeks will be there so
So
that we
it's
can
up to
complete it?
you. It's up to you. The total content which is available, I think, is around 14 hours, right? So it's a recorded content. Okay, so it's a recorded on-demand content. Whenever you enroll for that particular course, you can go through on your pace. You want to finish it in one day, in one sitting. 14 hours. 14 hours is what you get. And if you wanted to go through everything and then start practicing alongside, so I think each hour will require you to have a practice of at least 3 hours, right? So we have around, I think, how much, 28 and around 42 hours, I believe.
Okay, well,
So 2 weeks or 3 weeks maximum, you will be able to understand almost every individual component, and then you are good to go with your implementations.
gee, right, sir.
So I can see in chat, quite good number of people are interacting with each other, and this is what is good. I think you can connect with each other and work it out on your problem statements not problem statement, but you can share your experiences with each other, your learnings with each other, and that I think solves the purpose what I'm here for. Right. So I think the time in India is around 11. So let me see how many countries are here. Like people from how many countries are here today? Like from last two sessions, we were having it from around 5-6 countries. So can I see? Can you just type in chat from which place you are? Great, Yogita, India, India. There's Sergey is from Spain, Heather from Iraq. Great, Rupali from India. India is has a majority here. Great, Kapil is from Indore. So, how many of you have attended for the first time? I think as for what I can remember is there are around four. There should be a thing. No, not four. There are three. There must be three people who are first time. So Nazir is first time. Ajaz is I think first time.
सवाल पूछना कि मैंने ब्लॉग ही ना कर देना.
Mazaji, I think you can mute yourself. Okay, I think we can stop our session right now. It's almost 11. 2 hours we have spent today. This is a quality time which we have spent, and I hope you must have learned something new today, and it will scale up the way you work on your problem statement. So thank you very much, everyone, for joining in. Thank you very much for all the appreciations you have given to us. Thank you to the community for connecting with each other. I am open if you can, if you can share some content for Cloudsim tutorials.online platform. I'm open to that. You can mail me. I've already provided my email, that is hello@superbits.com. Uh, and with that, I think we can have our session closed for today. I think Lakshmi is saying something. Yes, yeah, let's wait and think. Let us also get connected in Google group by joining. I think I'm already here. If anyone wants to join in this to this particular group, this is a great group. That is Cloudsim @ googlegroups.com. I think I can copy it. No, I can just simply type Cloudsim. Okay, I think Lakshmi has already sent it to everyone. So you can also join to this particular group. This is a great group, and this is the group where the developers of Cloudsim are being no, moderating. So you can go through this group as well. There is another group that is Cloudsim Plus, right, which is another branch which is being built by very good team. They have been funded for their research work, and they are working quite good. So in case if you are working on uh, integrating the different kind of what do you call the data set, you can go through that particular tool as well, right? So thank you very much, and keep doing the practice. And definitely, practice is something which is required. And hopefully, maybe within 1 or 2 days, I will be sending you the recording of this particular session. And I think we can close our session right now. So thank you very much. Bye bye. See you all in the next Sunday live. I'll be uh, getting on with the new topic on that, and registrations will be provided through the email addresses which you have already provided, or through the newsletter which is there on events.